Hi students, welcome to my YouTube channel SADHIK Physics, Physics Made is Easy. So today we will learn center of mass in one shot. So if you really see this complete video, therefore you will get full clarity on the center of mass, which is useful for NEET and IIT-JEE and all the competitive examinations. So let us dive into our video. First of all, let us see what is meant by the center of mass. So you might have played so many times, like you will take one scale, like let us take this is one stick, this is one stick here, okay, don't think that I am showing this one, So here if you are able to balance, I am asking you to able to balance this one. Therefore, if I am keeping here, therefore it is falling. Why it is falling toward this side? Because the total center of gravity is acting at this point, it is making the torque at this point. That's why the torque is created, it is rotated like this. Suppose here, anywhere, Suppose if I am shifting toward this side, therefore again it is torque, Therefore it is rotating like this, means this side the torque is created, So again it is shifted to its here, Therefore again torque it is created like this. So slightly I will shift it here, Therefore torque is created toward this side. That means this side weight is more, this side torque is creating. That means it is lying between these two. So let us see, therefore here we are able to balance properly. Exactly I am able to balance here now, slightly, okay. So maybe due to here I am able to balance it, right. So this point this point is a total mass of this object, is concentrated at this point, that is called center of mass, or the total weight is concentrated at this point, that is called center of gravity. So therefore in the kids formula, they will study the center of mass, and the name itself is the center of mass. That means total mass is concentrated at that point. Clear? So, but real definition is what? So upon to this object, so therefore what is the definition of real definition? Upon to this object, so I have to apply one force at any one point, so that this object will go purely like a translator motion. Right? At what point I should apply the force? So that point we will call it as like a center of mass. That means if I am applying here, therefore it is undergoing rotational motion. If I am applying here, it is undergoing rotational motion. So therefore if I am applying the force, at one point you need to apply, or at one line we have to apply. So therefore the object will undergo like a pure translatory motion. Suppose I am taking here, this is your balancing point. So here I am applying the force, therefore it is going right like this. You understanding? So this point we will call it as like a center of mass. Center of mass means what? The point where we need to apply the force, so that the object will undergo like a pure translatory motion. Right? So not rotational motion, pure translatory motion. That's why we studied object is moving, like one ball is moving with a certain speed like 5 meters per second. Means what? That ball, therefore where we are exerting the force, we are exerting the force at the center of mass. That ball is assumed to be like a point mass, that's why we used it as like a directly velocity and all this one. But if it is like extended mass and not different objects, so there where you need to apply the force, compulsory at the center of mass, you need to apply the force, so that it will undergo like a pure translator motion. Right? So therefore some more points, So this is the center of mass. Center of mass means what? What is the unit of center of mass? Actually center of mass is nothing but a position. That means it's not like a mass, time, speed, acceleration, not like that, So center of mass is nothing but a one position, like a one point. So like x-axis and y-axis, you will find x comma y, like that. So center of mass is nothing but a one position, that is nothing but a distance. From therefore this center of mass, where you are calculating, from this end or from other end, right? So where you are calculating the center of mass now, right? So therefore here from this end means from this how much distance here now, from this one, So from this one, therefore how much distance it is there, right? So like that, therefore center of mass is nothing but one position. Position means compulsory you require x-axis and y-axis, So all the x-axis and y-axis distances will be measured from the origin. So compulsory to calculate the center of mass, you require a frame of reference, right? Like x-axis and y-axis, compulsory you have to locate it from certain from one start frame, therefore you need to find it. So the position of the center of mass will not be depend upon from the position of the center of mass. From the frame, from where, from which point you are locating. No, it does not depend upon position, right? So I mean the center of mass will not be depend upon the frame where you are choosing, no. So it depends upon only on the mass and mass distribution onto this, right? So from where you are measuring the center of mass, no, therefore the answer you will get it as different value. So but the position of the center of mass, the center of mass of this body, it will be because of due to this mass distribution only. It does not depend upon where you are, from where you are calculating, from which far away you are calculating, doesn't depend on to this. So therefore here center of mass depends upon the mass and mass distribution. Clear? So also the center of mass, no, what will happen now? So it sometimes it may lie on the object, no, or it may not lie on the object. That means it may fall outside the object. Where the center of mass is located, no, at that point mass need be present or need not to be present. Like if you take one bangle is there or one ring is there, the center of mass of the ring is at the center. At that center there is no mass is present, no. So therefore where the center of mass is falling, at that point mass need not to be present, or it need not to be lie on the object, it may lie outside the object also. Clear? And general thing, no. So like one uniform rod is there, I'll keep it aside. So one uniform rod is there, right? So one uniform rod is there, so therefore the center of mass it will lies exactly at the midpoint, right? So one ring is there, so center of that ring is what? A uniform ring. Therefore the center of mass will lies at the, therefore the center of mass of the ring, so it will lies at the center, right? Uniform ring. So therefore a uniform objects, no, their geometrical center will be there, a center of mass. Isn't? So let us see mathematically how you can calculate for a right. In this video I will explain so the concept and different problems which will be helpful for all the competitive examinations, even for teacher recruitment, right? All right, also it will be helpful for you. Compulsory you can expect the question. So let us see. So first let us go for the center of mass, right? How the center of mass is there. Suppose there is one object is there. Now this is one general object. Upon to this one, no, some masses are there, the masses, right? So here you are taking one frame, no. So from here you are calculating the distance. This is having mass m1. So this is kept at a distance is r1 vector. So therefore this is having mass m2, having the position vector is r2. So therefore this is your mass m3. So position vector is r3. So therefore the center of mass of all these three objects, no, will be lying at one point here, no. So here this it will be your RCM, this position vector. How to calculate it now? Therefore very simple one, no, very easily you can calculate it, no. Let us see, right? So therefore RCM, so you can write down m1 r1 vector plus m2 r2 vector plus m3 r3 vector, so on, by m1 plus m2 plus m3, so on. This is your formula to calculate the center of mass. So you might have studied that XCM, m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, YCM, ZCM. But in terms of vectors, no, in one point it will be over now, right? Always we will try to use this concept onto this one, no, so that you can solve the problems very easily. Now suppose if center of mass is lies at origin means what? This will become like a zero vector, right? That means 0, multiply this one 0. Therefore m1 r1 vector plus m2 r2 vector plus m3 r3 vector, it will be equal to 0. Clear? Right? So sometimes the particles are changing its positions now. So therefore the shift in the center of mass it can be calculated as very simple way, shift in center of mass. That means if this particle is shifted here, center of mass also will be shifted, no? That means the change in the displacement. So similarly delta RCM, it will be equal to m1 into delta r1. That means change in the the change vector, right? So position change vector m2 delta r2, so you can write down so on by m1 plus m2. Like this also so many times the questions are coming in the examination. No? We will also do 1 or 2 questions related to this. Clear? Now suppose if these particles are moving, with different speeds here, no, v1 like this, no, what will be the velocity of the center of mass? You can calculate it as, therefore here by differentiating this one, no, therefore you can calculate the velocity of the center of mass, no, that is vcm drcm by dt. That is nothing but again velocity of one particle m1 v1 vector plus m2 v2 vector, so on by m1 plus m2 plus so on. This is your velocity of the center of mass, no, and therefore here, so again if it is accelerating, no, therefore we can rewrite here also we can write it, no. So total mass of this one, no, taken here, no, total mass into velocity of the center of mass, this is nothing but a momentum of the center of mass, can be taken as momentum of the first particle plus momentum of the second particle, so on. That means the total body momentum will be equal to the momentum of sum of the momentum of each particles. Now clear? Now acceleration of the center of mass, no, so therefore you can write down dvcm by dt, so therefore here m1 a1 vector plus m2 a2 vector, acceleration of the particles, now by total mass, right? Or you can write down this is nothing but so this formula you can write it as still more modified formula, no, right? It will be equal to, so force on the first particle plus force on the second particle, so on, divided by the total mass of this one, no, total mass. Clear? Or it will be equal to force on the center of mass, it will be equal to total mass, acceleration of the center of mass, it will be equal to force on the first particle plus force on the second particle, so on. So therefore in this way, therefore just now I told you, no, therefore if an object will undergo like a pure translator motion, no, we should exert the force at the center of mass, no, that will be equal to force acting on the first particle, force acting on the second particle, this total we can rewrite this formula. Even conservation of your linear momentum also will take place, no. So I already discussed the conservation of linear momentum, so both problems and everything, no, in the past video, please check it. So based on the law of conservation of linear momentum, that means if an, right, if external force acting on the system is 0, so therefore here change in momentum of the center of mass, no, also will be equal to 0. That means total initial momentum will be equal to total final momentum. Now this will lead to the law of conservation of linear momentum. Now clear? So similarly, if any object is moving, therefore we can use our equation of motion, no. So how? Let us write it now. We know that if it is acceleration is constant, that means acceleration of the center of mass is constant, so therefore v is equals to u plus at. That means velocity of the center of mass, final velocity, initial velocity of the center of mass, acceleration of the center of mass, no, you can rewrite it as r s is equals to ut plus half a t square. That means, so displacement of your center of mass, initial velocity of the center of mass, acceleration of the velocity of acceleration of your center of mass, right? So we can use it as v square minus u square is equals to 2as. You can use all these equations, no, but all these equations are calculated at the center of mass only. So go through this concept, no, only these concepts are there. So we'll go for different questions based on this one. No? And also one more important formula is there, no, this if you know the masses, no, individual masses, no, then you can calculate it. But if you are asking for to calculate the for this pen, no, so it is having infinite number of atoms inside this one, no, molecules are there. So right. So therefore, how to calculate for the distribution of this one, no? Center of mass, you can rewrite it as RCM, it will be equal to integral. So R into dm by integral dm. So this it will be your equation for our center of mass for a distributed mass. Clear? So we'll use this formula to calculate the problems, this formula to calculate the all the problems, no, based on the center of mass. Right? We'll go for the numerical questions, no, based on this. Right? We'll do some questions on this one, no. Let us see here, no. Okay, this is also one of the important point, no. Let us see. I already told you a uniformly symmetrical objects, no, their geometrical center will be their center of mass. Like if you take it as one disc is there or a ring is there, therefore the uniform ring, no, center will be your the center of mass. Or if you take it as like a one square is there, no, therefore suppose let us take this one, no, there is a, so there is a one ring is there, no, therefore their center of mass will be their geometrical center, no. Or if you take it as like a one square is there, no, suppose here there is a square is there, right. So square or a rectangle, no, therefore their geometrical center, so will be your, so center of mass, disc or a frame or anything, no, but it should be compulsory uniform. Here everything, everywhere the uniformly distributed, no. Here it is thick is there, here thin is there, means definitely the center of mass will not lie in the geometrical center onto this. Clear? So therefore all these geometrical shape objects, no, their geometrical center will be the center of mass. Here some of this is given, no, but here NEET level is not important, no. So but JEE mains and IIT advanced, no, compulsory these formulas, no, compulsory you need to remember, no, just one or two things, no. Here we are not no need of derivation onto this one, no. So one or two things we will see the derivation also. So here semicircular ring is there, therefore the center of mass it will be at the distance of 2r by pi, 2r by pi. So semicircular disc is there, therefore 4r by 3 pi. So hemispherical shell is there, no, r by 2, right. So like this, here in this one, no, cone is there, no, this is solid cone is there, therefore the center of mass from the base, no, it will be at h by 4. Here hollow cone is there, the center of mass will be from the base, from the base, no, it will be h by 3. This will use it. So if any arc is there, no, like r sin theta by theta, so 2r sin theta by theta. Okay. So these are the things, no. So try to remember. So we'll use in our calculations on this. Clear? If you really want, you can take a one screenshot and you can save it. Now let us see one question here, no. Let us see here, no, there are here there are three particles. This is one simple question, no. Let us go for simple and then afterwards complicated. All different models, no, will cover it here. So 1 kg is there, it is concentrated at 0, 0. This 2 kg is there at this point, no. This point is like we want to calculate the center of mass from here. From anywhere you can calculate, from here or here or here, anywhere you want to calculate. One important point you need to remember for calculation of the center of mass, no, location of the origin or from where you are calculating. So at that point you make it as like a x-axis and y-axis. So you draw it so that therefore at that point you make it at like a origin onto this. This point if you do it, no, center of mass problems are very, very simple, right. Let us see here, no. Therefore here we want to calculate here, no. So this distance, this 2 kg distance, no, where it is down, therefore this is r, this is r1, this 1 kg it will be 0 vector, why, because it is lying at the origin. R2 it will be equal to 2 I cap, why, because along the x-axis this distance is 2, 0, right. So similarly therefore this 3 kg, this is nothing but a 3 j cap. So now we can rewrite it as this center of mass formula, no. Therefore RCM you can write down, this is 1 kg at 0 vector plus 2 kg into 2 I cap plus therefore 3 kg 3 j cap, this is 3 j cap by 1, right. So here 1 plus 2 plus 3. So how much it will be? 4i plus 9j by therefore 6 now. Therefore 4 by 6 I cap plus 9 by 6 j cap. Just still more simplified no. Therefore it is 2 by 3 I cap plus 3 2s are 3 3s are. Therefore 3 by 2 j cap. This is your center of mass. Or if you want to calculate in the points no, therefore 2 comma 3 along the x axis and 3 comma 2 along the y axis. This is your center of mass. Clear? In this way you can solve the problems no, very easily. Always denote like a vectors. Very simple one no. Here therefore here already everything is given on to this one no. If there is not given also you have to find it height of a equilateral triangle, all this one you can calculate it now, right. So here again the same story, therefore here we are calculating from here. This distance is nothing but suppose here this is r1 is 0 vector. So suppose this is your r2 vector. R2 vector can be written as like a I cap. So this is your R3 vector. So a by 2 I cap plus root 3 by 2 into a j cap. You know these points, no? You can write down the vectors, right? So here, so we can rewrite it as RCM. We can write down M1 R1. This is 1 kg into 0 vector plus 2 kg into what is this 2 vector now? A I cap plus 3 kg into therefore a by 2 I cap plus root 3 a by 2 j cap divided by 1 plus 2 plus 3. Therefore here it will be how much now? 3a multiplied no. So 3a I cap plus therefore 3a by 2 I cap plus 3 root 3 by 2 a j cap divided by this is 6 now. Simplify, therefore take all a's as common now. Therefore 3a plus 3a by 2 I cap 3 root 3 by 2a into j cap divided by 6. Now this is 6 plus therefore 9a by 2 divided by 6 no, therefore into 6 I cap 3 root 3 by 2 into 6 a j cap. Clear? So 3 2s are 3 3s are 3a by 4 I cap 3 1s are 3 2s are root 3a by 4 j cap. So what it will be your center of mass no? You can rewrite it as 3a by 4 comma, so root 3 a by 4, this it will be your center of mass now. Clear? So therefore you can calculate the problems like this no. Now right, this also same concept no. So therefore here you can rewrite it as this is r1 vector, that is 0 because at this point no, this is your r2 vector a I cap, this is your r4 vector a j cap, r3 vector a I cap a j cap. Now the same thing RCM, you can write down 1 into 0 vector because this one no, plus 2 into this is your a I cap plus 3 into a I cap plus a j cap plus 4 into a j cap divided by 1 plus 2 plus 3 plus 4. So like this you can solve this one no, it's very easy. So you can continue this question, no? So already everything is given, just simple mathematics, no? You can solve this problem, no? Right? We'll see the similar type of question here, no? So here, but slightly one new learning will be there here, no? So we want to calculate the position of the center of mass from this origin here. From here, all these particles are lying along the x-axis only. So therefore, we can take it as like xcm, no? Therefore, this first point, no, where it is there, it is 1, and therefore it will be at a 2. So what is the distance now? Therefore, xcm, you can write down m1 x1 plus m2 x2 plus m3 x3, so on, mn xn by m1 plus m2 plus m3, so on, plus mn. Clear? So therefore 1 kg into distance is how much now? 1, plus 2 kg into distance is 2, plus 3 kg into distance is 3. So plus n kg into distance is n, divided by 1 plus 2 plus 3, it is n. Therefore, here what you will get it now? 1 square plus 2 square plus 3 square, so on, plus n square by 1 plus 2 plus 3 plus so on plus n. Clear? This is sum of your square terms, no? And this is sum of your n terms. So what is your sum of your square terms, no? So what is the formula we studied, no? Therefore n into, so therefore n plus 1 into 2n plus 1 divided by 6, no? This is your sum of your n square terms, no? By sum of your n terms, no? n into n plus 1 divided by 2. Clear? So how much will get it now? Therefore this n get cancelled, n plus 1 get cancelled, this will get cancelled, no? So what you will get it now? Therefore 2n plus 1 divided by 3. So this it will be your xcm. Clear? So therefore here learning thing is what? Sum of your square terms, no? This is like, if you go on doing the different questions, no? So you will be using like different formulas, so that you will be learning all these different varieties of questions now. Now here, right, here therefore here 2 point masses are there. It's a very simple one, no? But how to solve the problems very easily, I will tell you very quickly. 1 kg, this is your 1 kg, and here 2 kg separated by this one. Find the position of the center of mass. From which one now? Therefore from m1 if you want to calculate, no? m1 is at origin, no? m2 is at some distance is how much, no? 3 meter distance, right? So simple formula, directly now we can write down, therefore x is equals to, this is at origin, no? Therefore m1 into 0 plus m2 into at 3 meter divided by, so m1 plus m2. Like this you can solve the problems, no? Very easily. So m2 is how much now? 2 kg into 3 divided by 1 plus 2. So this will get cancelled. Therefore 2 meters. So where the center of mass it will lies, no? At 2 meters. That means here, somewhere here. So you try to observe here, no? The center of mass is always here. This is 2 kg. This is 2 kg. This is 1 kg. 1 kg is a smaller object. 2 kg is a larger object. That means the center of mass is always lies near to the heavier mass head, right? So therefore the center of mass is always falls near to the, right? So near to the heavier mass side now. Clear? So in this way, therefore you can remember onto this one, no? So you can solve these problems, no? Clear? Now let us go for this one, no? Yeah. This is one rod is there now. This is one rod. So how to calculate it now? Therefore here I already told you. Therefore so integration now. Therefore it is uniformly distributed, no? For this one now we are going to consider one small amount of small mass here now. Therefore it is dm. What is this one now? Dx. So at what distance is there now? At x distance now we are going to take it. So therefore we know that dm by dx. This is nothing but a linear mass density. That means linear mass density of length is L. Therefore this linear mass density is lambda, it is given as like a 2x. This is not constant. Clear? So dm value you got it now. How much it will be? Dm is equals to 2x plus 2x into dx. Now you know that center of mass, how to do this problem now. Therefore x it will be equal to integral x dm by integral dm. So there RCM means this only lying along the x axis, no, that's why I am taking, no. If it is lying along the x axis and y axis, RCM we are going to take it now. Therefore at what distance we are taking now? Therefore x distance, no, into what is the dm now? Therefore 2x into dx. What is the length of this one now? From where to where? 0 to L, because it is total length is L, 0 to L. So integral 2x into dx, so 0 to L, because dm, no, therefore directly substitute and simple integration here, no. Therefore 2 into x square integration is nothing but a x cube by 3, therefore 0 to L divided by 2 into, therefore x square by 2, 0 to L. This will get cancelled out, no. That is L cube by 3 by L square by 2. Clear? So that is L cube by 3 into 2 by L square get cancelled out, no. Therefore 2L by 3, so will be your center of mass. What is the center of mass? We got it, no. That is, therefore from here, no, therefore x is equals to 2L by 3. Clear? In this way you can solve the problems, no, very easily. Right. Same type of question, but a slightly variation is given, no. Right. Mass per unit length of a non-uniform rod, it is given. So mu is equals to lambda into x square. Lambda is constant, x is a distance from one of its end. The distance of the center of mass of this one of length is L. So again the same thing, no. So therefore here it will be, you can take it as like a one rod is there, no. This is one rod. So you have to take one small, right. So here, no, small amount of dm and dx at a distance is x, no. Clear? So therefore here dm by dx it will be equal to, that is nothing but a mu, linear mass density, that is nothing but a lambda into x square. Lambda is constant. So dm is equals to lambda into x square into dx. So again the same formula here, no. Therefore xcm, because it is lying along the x axis, no. So integral x dm divided by integral dm. So try to substitute here, no. Therefore x into lambda into x square into dx divided by lambda into x square into dx. So 0 to L, 0 to L. Please try to continue this one, no? So continue integration, basic integration only. So you can solve the problem very easily. Clear? So one more question, no, we'll take it here, no. Same type of question. So slightly, right here, this is once or twice, no, the questions has come based on this one, no. Again the same length is L, no. Slightly lengthier calculation is there, not lengthy. So just so here let us take, this is on one rod now. Therefore here again, therefore upon to this rod, no, therefore this is non-uniform rod, no, we are going to take it as like a small amount of dm of length dx, so which is at a distance is x, no. Total length it will be equal to L. Clear? So again dm by dx is equals to, therefore lambda, so therefore a plus bx, right. So that is nothing but a dm, you can take it as now a plus bx is equals to dx. Clear? Substitute here, no. Therefore x is equals to integral x dm divided by integral dm, 0 to L, 0 to L, because it is length is given now. Clear? Now integration of x into a plus bx into dx divided by integral a plus bx into dx, 0 to L, so 0 to L. So just further again continue this integration, no. Ax bx square separately you do it this one, no. So therefore still those who don't know the integration, no, please for them, no, I am expanding. So if not, no, please go through the next concept now, right. So here a into x dx plus this I am multiplying, no. Therefore here b into x square dx, 0 to L, 0 to L, divided by integral a is given how much now, here a is outside, therefore into dx, 0 to L plus b integral x dx 0 to L. Clear? So you can rewrite it as a into x square by 2 0 to L plus here b into x cube by 3 0 to L. Here a into x 0 to L plus b into x square by 2 0 to L. Like so, therefore use the upper limit and lower limit. No, so simplify. So you can further you can solve it. You can get your answer very easily. Clear? So this is your therefore whatever the formulas we studied, no, that for non-uniform onto this, like this only we need to derive it, no, different situations. So these derivations will not be asked, no, in any of the competitive examination, no, but applicative way only they will go. So mostly, so let us go for this one, no, right. So this is your distributive like rods are there, no, right. Let us see, no. These are like some uniform rods are there, no. So therefore you know that for a uniform rod, no, the center of mass is going to lies like at the geometrical center. Clear? So therefore at geometrical center, no, this is totally L of this one, no. Therefore exactly this total mass it will be lies at what distance now? Therefore it will be L by 2. So therefore this also mass it is going to lies, no, at a distance of L by 2. So here we can relocate it this one, no. That means total mass is M, where it is found, no, therefore L by 2 distance. Here total mass is found, no, so where L by 2 distance. No need to consider anything onto this. This is uniform onto this. Clear? Now again you can calculate what will be the center of mass of this one, no. Here particle masses are there. Therefore here you can write down RCM, you can write down M1, this totally M of this one, no, into what is the distance now? L by 2 along the x-axis. This is your x-axis, right. So identical masses, let us take this as here M. Clear? So similarly M into the distance is how much now? L by 2 into j cap. Clear? So divided by, so M plus M. Clear? So in this way, a simple way you can solve it, no. Therefore M into L by 2 taken note, no. So M into L by 2 into I plus j by therefore 2M. So get cancel out, no. Therefore L by 4 I cap plus j cap. So what will be the center of mass here, no? Therefore L by 4 comma L by 4, this it will be your center of mass. Clear? Right? Now let us go for one more question, no? This also similar way. Right? This also similar way, no? So 3 rods are there, no? Masses are placed, no? So center of mass of the coordinate system now, right? See here, simple thing, no? Again this rod is there, right? This rod is having 3 rods of same mass, therefore same mass. So what is this one now? This distance is how much, no? The total mass it will be equal to M, where it is going to lie, no? It is A by 2 distance. Clear? So this also, therefore again M, so it is distance is nothing but A by 2. So this also it will be M. What is the distance here now? This distance is nothing but A by, this distance is A, this distance is A, therefore this distance is nothing but root 2A, therefore total distance is root 2A, but A by root 2. But we don't want this A by root 2, we want how much amount of x distance here, x distance. Clear? Therefore here that is sorry here, no, therefore here this distance we require, no, and here this distance we require. That means here you can write it as like a 45 degree because these two are same, and this is 90 degree, right? So this total distance is root 2 into A, this distance is A by root 2, this it will be A by, okay, cos 45, no, right. So you can rewrite it as sin 45 this distance, therefore suppose it is y, sin 45 opposite side by hypotenuse a by root 2. So sin 45 is also 1 by root 2. Therefore y is equals to, therefore a by root 2 into root 2, therefore a by 2. This also a by 2. So this point you got it as a by 2 comma a by 2 similarly. Clear? So this all we are going to locate it here, no? So here we are going to locate it, no? Same mass, no? Distance is a by 2. Same mass, distance is a by 2. Same mass a by 2 comma a by 2, right? Now we can rewrite it as RCM. How much it will be? M into a by 2 I cap plus this is m into a by 2 j cap plus m into a by 2 I plus a by 2 j. Clear? So divided by total mass is how much, no? 3m. So all this is therefore all a by 2s you can take it out onto this one, no? M into a by 2. So I plus j divided by 3m. So this m get cancelled, a by 6. So I plus I is nothing but 2i plus 2j. Therefore 2 taken out onto this one, no? A by 3 I cap plus j cap. So what it will be the center of mass here, no? That is nothing but a by 3 comma a by 3. This is your center of mass. Understood? So just you have to use all basic mathematics, no? So that's why if you really want to learn the physics, no, compulsory the math should be very, very stronger. Correct? So most of the students know, therefore they will take by PC, right? So thinking that math is difficult. So we want to escape from the math. If you escape from the math, no, but physics is there, no, compulsory the math is required. Those who are very stronger in physics, no, I mean those who are stronger in mathematics, no, so they only should be take mostly for BPC, not for difficulty in maths, no, that's why you go for BPC. No, it's a wrong one, no, right? So those who are strong in mathematics, so up to the 10th class level, they only have to select the BPC, right? So this is one of the myth, no, most of the students they will confuse in this one, no, and they will come and trap in the physics onto this. Clear? So right, try to learn the mathematics thoroughly. So this also one same concept here, no? Each plate of side it is A and mass is m. Clear? Now therefore here this is your each plate is A, side is A. Okay. So we want to calculate the center of mass, no? So here the center of mass of this one, no, it will be lies at this point. We can locate it now. All this one, no, this mass is m. Where it is there now? This total distance is a, but in this one now a by 2. That means here one mass is there. So this is distance is a by 2 comma a by 2. And here one more mass it will be there. What is the distance here now? Here it will be there. Mass is m, but this distance is a plus a by 2. A plus a by 2 is nothing but 3a by 2 comma, therefore this distance is like a by 2. And here, so one more mass it will be there at this point, no, this mass. So what is this distance now? This distance is nothing but 3a by 2. So this distance is also nothing but 3a by 2. 3a by 2 comma 3a by 2. Now you got these three masses, no? Then you can calculate RCM and onto this one, no? Same question, same concept, no? So again, so here it will be here it will be the mass is m into, therefore a by 2 I cap plus a by 2 j cap. This for this one, no, for this distance. For this distance is how much now? M into this distance, that is 3a by 2 I cap plus a by 2 j cap plus here m into, so 3a by 2 3a by 2 I cap plus 3a by 2 j cap. Now therefore it will be totally mass is 3m. So let us shift toward this one, toward this side. Now simplify. So in all this one, a by 2 is common, no? M and a by 2 is common. M into a by 2 taken common, no? Therefore I plus j. Okay, we'll take it as in the simple one, single one, no? This is your I plus j plus a by 2 gone, no? 3i plus j cap. In this one, no? 3i plus 3j divided by 3m. So m get cancelled out, no? A by 6. So I plus 3i plus this one, no? Therefore 6 plus 7. 7i plus I plus I. So I'm sorry, j plus j. So 2j plus this one, no? 5j. So you can write down 7a by 6 I cap, 5a by 6 j cap. What will be the center of mass here, no? Center of mass of this one, no? That is nothing but a 7a by 6 comma 5a by 6. This it will be your answer. Clear? So right. So here we'll see one more problem, no? Therefore here this is a disk is there and this is one square plate is there, no? So if their masses are equal, so they are telling calculate the different of center of mass, no? If the masses are equal and densities are equal. So therefore here we can calculate, no, center of mass. How we are calculate, no, center of mass for masses are equal, no? This is a disk, no, where the mass is located at this point. This is your square plate, no, center of mass it will be exactly located at this point. So that means I will calculate the center of mass from this point. Clear? So therefore at this point, no, from here, so here it is at a distance, no, so masses are equal. That means this mass is mass of this one, no, it is a. So this distance is a, no, therefore it is a, and this total mass is how much, no, it will be also it is m. So this is a and this is a, and this total distance is 2a, in that is half, no, that is nothing but a. This is a, this is a, this is a. Total distance is how much, no, it will be 3a. Clear? Now we can calculate it, no. Therefore here all these 3 points, no, xcm. So therefore m into a, so plus m into 3a divided by therefore 2m. What you will get it now? Therefore 4m a divided by 2m get cancelled out, no. Therefore 2a. So 2a means what? Exactly the center of mass, no, going to lie at this point. At this point, this is the center of mass, no. So if their masses are equal, therefore it is exactly falls at 2a. Clear? So now what they are asking, what they are telling now, if the densities are equal. Densities are equal means masses are not same. Why? Because this area is different, our volume is different now. Therefore this area is also different after this. So therefore we have to calculate the masses of this one, no. So let us see. Therefore this mass of this one, no, mass is equals to m1. We can write down density. Density is nothing but a therefore density is nothing but a mass by volume. Okay, mass is equals to density into volume. Volume is nothing but a area into thickness. Clear? So density is how much now? Densities are equal, no. Density into area. Area is how much now? Pi a square into t. This is your this is the mass of this circular disc now. Therefore mass of this one now m2, we can rewrite it as m2. So we can write it as how much it will be? This side it is 2a and this side is also 2a. So density into area is how much now? 2a into 2a. So therefore 2a into 2a is equals to into t. This is your mass, right? So therefore here xcm we can rewrite it as, so m1 is how much now? Density, right? So density into a square into t. Therefore this you can take it as constant here, no. Why? Because here some constant, no. K we can take it as density into a square into t, because this is same common. Therefore pi into k. Therefore here also you can write down. Therefore here density into a square into t, that means 4k. Clear? This is your masses, no. So we can rewrite it as mass m1. M1 is how much now? M1 is nothing but pi k into distance is a here, no? Plus therefore m2 distance is mt is how much now? 4k into distance is how much now? 3a divided by therefore it will be how much now? So total mass of this one, no? Therefore ka plus 4k and pi k, sorry here, no? pi k. So here what you can write it now? K taken common here, no? Therefore pi plus 4, 4 into 3, so it is 12. Therefore this is a divided by pi plus 4. Therefore here it is into denominator is k. Therefore this will get cancelled out, no? So x is equals to, therefore so here you can write it as pi plus 12 into a divided by pi plus 4. Clear? So in this way you can calculate so different if they are having the different densities. Clear? So now, right students, we will do one more question now. Here cutting of there is a one disc is there, no? We are cutting onto this, right? How to calculate the cutting of disc, no? Therefore the center of mass of this. So first let us understand very clearly what is given this question, no? So there is a disc is there, therefore there is a one disc is there, no? Right? Of radius is r. Let us take this is your disc, right? So therefore here this is a disc, no? Right? Whose radius is r, right? And uniform thin sheet of metal, a hole of radius r by 2 is now cut from the disc. So with the hole being at the tangent on the and the rim of this, the distance of the center of mass. That means what is telling now? He is telling that he is cutting the disc here now. Therefore he is cutting this part. This total radius is r, that means this distance is nothing but r by 2. Clear? This radius is r, this distance is radius is r by 2. We are cutting onto this. So this part is removed. When this part is removed, what will happen now? Always the center of mass, no, it will be shifted toward the heavier mass side. That means, so remaining part is there, no, therefore the center of mass it will be able to shift toward this side. Therefore here this distance now we have to calculate the distance of the center of mass from the original disc now. How to calculate it now? Very simple one, no? Just logically you try to observe this. Very easily you can solve these questions, no? Let us see. So first of all you have to calculate the total mass of the disc, no? So is nothing but a pi. What is the total mass of the disc, no? This is m is equals to density. Density is nothing but a area into thickness. Pi r square into thickness, right? Density into density here now. Clear? So this is total mass of the disc now. Therefore here what will be the mass of the removed part now? Therefore mass of the removed part is nothing but a density into pi into r by 2 whole square into thickness is t. How much it will be? So density into pi r square into thickness is t divided by 4. So this is pi r square, this one, no? Therefore it will be m by 4. So m by 4 mass is removed. So how to calculate the center of mass now? Therefore removed means we have to subtract it now, center of mass, that's all. Clear? So the center of mass of this one, no, minus center of mass of this. So therefore the center of mass, how to calculate it now? Very simple one, no? Center of mass of this one, no? So here m into m1 a1 plus m1 x1 plus m2 x2 by m1 plus m2, no? Here we are removing. That means, so therefore whole body of this one, no? Whole body. So mass of this one, no? Into the center of mass of this one, no? Therefore complete center of mass of this. And we are removing this one, no? That means we are removing this one, no? Therefore minus. So amount of mass is removed into the center of mass. Therefore we have to take the center of mass from here. So what is this distance now? Therefore the center of mass of this distance, that is nothing but x2 divided by m minus m. Simple thing, no? Therefore, you can solve it, no, very easily. So, total mass of this one is how much now? M. Where it is total mass is going to lie now at the origin, no? 0 minus how much amount of removed part is there? Therefore, M by 4. What is the distance now from the center of mass of this complete disk to here? What is this distance now? This distance is nothing but R by 2. Therefore, R by 2 divided by, therefore, M minus M by 4. That's all. Very easily you can solve it, no? So, then you can calculate it now. How much it will be? So, here minus M R by 8. Therefore, here it will be, so 4 minus, therefore 3 M by 4. Therefore, minus M R by 8 into 4 by 3 M. 4 1s are 4 2s are M may get cancelled out, no? Therefore, minus R by 6. That means, so where it will be shift, no? Here minus means why it is coming back now. Therefore, minus R by 6 distance, no? From here, the center of mass it will be present. Clear? So, in this way, you can solve the problems, no? Right? So, till now is already still lengthy, it is over, no? There is some problems are there. So, in the motion of a center of mass, no? So, we will do as a part 2 and this one, no, on the center of mass of this, right? So, part 1 and part 2. So, combinedly try to observe, try to see it, no? So that you can able to get the clarity onto this, right? Right, students, no? Thank you. Thank you for watching. Please subscribe to my channel and also watch part 2 problems on motion of a center of mass. Thank you.